like I said, we're doing stats, statistics, data handling, whatever you want to call it. It's completely up to you. But basically, it is looking at data and then analyzing it. Now, oh golly. Now, stats is a paper 2 concept. It is generally the first 2 questions of your paper 2 exam. It is generally about 20-ish marks, give or take. And so, yeah, 20 out of 150, you might not think that's a lot, but it's 20 marks that you can bang. Within your stat section, you should be getting bare minimum 80 to 100% for those first 2 questions. And in paper 2, the other easy section, or the section where you can bank marks, is analytical geometry with the circle, center, the circle, radii, tangents, all of that stuff that we've already had a look at. So those are the 2 sections in paper 2 where you should be banking your marks. Obviously, if you really enjoy trig or Euclidean, you're going to get marks there, but those are notoriously the sections that we struggle with. So bank your marks in stats and analytical so that you've got some wiggle room when it comes to trig and Euclidean geometry. Okay, stats is very easy, but stats is very calculator work based. Don't know if that's the right order of words, but you need a calculator to do stats. A, makes life easier. B, there's things that not you can't do without a calculator, but if you try to do them without a calculator, you're making your life so hard. Okay, so we're just going to run through a few definitions. I would like to do this quickly because it took about like 15 minutes in the other class. I don't want to spend 15 minutes on definitions. So I'm going to run through this quickly. I might ask you some, but I'm just going to go. Okay, so the first thing that we need to understand what it is the mean. Now I'm going to ask you in the chat while I write a few things down. What is the mean? How do you calculate it? You can put that in the chat for me if you want. Mean is represented by a symbol called X bar. It's quite literally an X with a bar on top of it. Nothing fancy there. And mean represents the average. Let's actually do this. Okay, so I asked how do we calculate it? No one's giving me an answer there, so that's somewhat disappointing. Your average is the sum of all your values divided by the number of values that you have. Now, basically what that means is if, for example, we wanted to calculate a class's average marks for a test, I would take all of your test marks, add them all up, divided by the number of students in the class. That's all an average is. Okay, can anyone tell me what the median is? Okay, the middle number, middle term, that's good, but really importantly, it has to be the middle number of an ordered data set. Now, when I say ordered, I mean we need to put it in ascending order. Okay, so we arrange it from smallest to biggest. That'll help us with other things later on as well. But it needs to be an ordered data set. 9 times out of 10, we do give you an ordered data set, but sometimes we don't, and you would need to first put it in order before you can go and find things like a median, your quartiles, etc., etc. Right, what's the mode? The number that appears the most times, the number that repeats the most times, awesome. The one that's most common, great. So I'm going to say the value with the highest frequency. And basically it means everything that you've said. I'm just choosing to say highest frequency because sometimes we give you frequency or tally tables, stuff like that. And so if you can see that it's got the highest frequency, it means it's repeated most often. Awesome. Does anyone know what standard deviation is? We work with it, but what is it? Okay, so I expected this. Don't stress. I think it's one of those that we work with, but like we don't actually know what it is. So your standard deviation, I'm going to write this down in a second, but my brain doesn't always go at the same pace. Standard deviation is a measure of spread around your mean. So basically, you've got your average, middle, sort of central value, which is your mean. And the standard deviation allows us to look at how spread out the data is on either side of our mean. Are data points quite close together to our mean, where we would have a small standard deviation? Or is our standard deviation quite big, sort of illustrating for the fact that our data points are more spread out or further away, more dispersed around our mean or central point? So standard deviation, someone said it's got something to do with quartiles. No, but it does have something to do with the spread of data, which quartiles also has to do with. So standard deviation is the measure of spread or dispersion around the mean. Okay, so basically it tells us how spread out is our data, or how closely clustered or spread out are our data points either side of our average or of our mean value. Okay, you'll all know this. What is the range? Nice. Luva, nice. Range, very simply put, it's also a measure of spread actually, but it's your maximum minus your minimum. Just be lazy, it can be highest minus lowest, whatever you want. It basically tells us what is the spread from each extreme. So for example, if we had a test and I said our range was 20, that means there's a difference of 20 marks or 20% or whatever from the lowest value, or the lowest mark to the highest mark. The smaller your range, the closer together your data points. Right, does anyone know what IQR stands for and how we calculate IQR? Nice. Okay, so we know it stands for interquartile range. How do we calculate it? Nice. Okay, so good. We take Q3 and we subtract Q1. Now, this is quartile, so Q3 and Q1 are quartile 1 and quartile 3, and we will do quartiles a bit later. Excuse me. There were words I was going to say, and again, my brain just had a brain fart. Right, so your quartiles, remember, split your data set up into 25% or into quarters. Q1 represents from 0 to 25%. Q3 represents from 75, and then above that would be 100. So Q3 and Q1 basically are the boundaries of the middle 50% of your data. And so what you're doing by finding the range is you're looking at just the middle 50%, which should contain like your average, your measures of central tendency, like your median, and you're looking at what is the spread between those points. So if, for example, again, your IQR was a smaller value, it means that the middle 50% is quite clustered together. Those data points are very, very close together. Whereas if it's a big value, it means that your spread of your middle 50% is much bigger. Those data points are not as similar or as close to each other. So IQR does a very similar thing to range. It's just now, rather than looking at the whole data set, you're looking at the middle 50% of the data and what its spread is. Okay, so let's take a screenshot of those because it is important that you know what these things are, and then to jump into an example. I've also got the dates there in case you've forgotten them. So when you have a look. Okay, let's have a see. Right, so this first example, we have got some winners of the Comrades Marathon, but let's read through. So, the Comrades Marathon is an ultra marathon of approximately 89 kilometers, which is run annually in KwaZulu-Natal between the cities of Durban and Pietermaritzburg. The table below summarizes the athletes who have, okay, the English was really bad there, who have achieved the most wins. So we've got a list of names and we've got how many wins they have. Now, in terms of like data, we are concerned with the number of wins. I'm not saying that the names aren't important. They have done something amazing. They should be recognized. But in terms of like our data analysis, we're looking at number of wins. Now, what you can see here is that it's just a random set of numbers. They're not in any sort of order, nothing like that. Now, this is where our calculator work is going to be quite useful. But before we do that, what I'm going to do is I'm just going to highlight the values that are the same. So what I mean by that is we've got a 4 and a 4. I'm sorry, we can be a motorbike outside. Someone's having a time. We've got 4 5s. Now, the reason I'm doing this is going to be very clear in a second when we move to our calculator. We've got a 9. We have got 7. We've got 3 3s. And we've got a 2. Okay, so got all of my data points. That's there. The first question is asking for the mean of the data. Now, you are absolutely more than welcome to just go type 4 plus 5 plus 9 plus 7 plus 3, blah, 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 on your calculator and divide it by the number of athletes we have. In this case, we've got 12 athletes. But we have a calculator to do this all for us. But later on, we're going to be asked for the standard deviation. We're going to use our calculator for that. So we're going to input our data immediately just that we can go and do all of these calculations. Now, you can't see that yet, but there's a calculator on my screen. So let's just share that. Just give me a thumbs up when you can see the calculator, please. Let's just also thumbs up if you can see. Great, 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 great. Okay, so let me get it back to where it needs to be. You've got your calculator in front of you. If you don't, I suggest you grab it because I'm going to talk you through how to find mean and standard deviation in this lesson. And then next week, we're going to talk about how to find the least squares regression line equation. Okay, so on your calculator, you want to go into a stats mode. Your calculator has lots of different modes depending on what you want to do. We want to do some stats. So we're going to go mode and we're going to select to stat. Depending on the type of calculator you have, stat might be a different option. And if you've got like a silver or white calculator, I want to say it's option 5. No, it's still stat. It's still 3. So ignore marbles. Okay, so stat. Once you've selected stat, for the purposes of what we want to do, we want to choose option 1, where it says VAR, stat variance. We're looking at mean, standard deviation, etc. So we're going to select 1. Now your calculator comes up with an X column and a frequency column. Now this is where having highlighted my numbers is useful. You are more than welcome to type in 4 equals 5 equals 9 equals 70 and just put them all in like that in your X column. All of the frequencies would be 1. That's fine. But particularly when you have large data sets where data points are repeated, the frequency is exactly what it says. How many times is this data point repeated? So if we go to the data point of 4 and we put that in, remember to push equal so it does actually enter. If I now go across to the frequency, 4 repeated twice. So I've now put 2 as my frequency. And what my calculator does is it says 4 plus 4. There's 2 4s, 4 plus 4 when I'm calculating my mean. Now we can go to the next value, which is 5. There were 4 of them. So in the frequency column, I would put 4. Again, if you want to just type them in and not care about the frequency, that's fine. Okay, so if your calculator is in front of you, which it should be, let's put in our data points. Whoopsie daisies. How we do it correctly? So I need to move back into my X column. 9, 7, 3. There were 3 of them. 1, 5, and then 2. Okay, you can double check that you have everything. If you go over to your frequency column and add them up, you should have 12, 4, 6, 10, 11, 12. I've got 12. Right now, once your data points are all in, don't panic, but you're going to push AC. Your data has not been deleted. It has just been said, okay, cool. We've now taken that data set that you've given us. We've put it into our memory storage. We're now going to be able to analyze it and do calculations on it. And this is now where we say shift, and we go above the number 1 where it says stat in yellow, and we push 1. So shift 1. Now again, we're looking at the option 4 that says VAR, variance. We click 4. I think that might be where some options are different, but as long as you're selecting the VAR one, it's not like I'm in football, soccer. And we can now make some selections. Okay, so N is number of. How many data points did you have? So we already know it's 12, but if I did select N and I push equal, there's 12 data points. Now, I want to do the mean. So I didn't want to select N. That's fine. I push AC again, shift 1, make my appropriate selection 4. And now I see number 2 has that X bar, which represents mean. And I click option 2. And when I push equals, it gives me what the mean for my data set is. So by using your calculation, I know it's tedious to type in all the data, but once it's in, it's in. Okay, so we've got an average of 4,58. Now, obviously, you can't win comrades 4,58 times, you win it 4 or 5 times. So realistically, this would be 5 wins. My advice is write the decimal, because that's generally what is marked. I don't know for whatever reason, maths isn't always super concerned about appropriate rounding. But if you feel that it's not an appropriate value for the context, just write next to it what would be appropriate. Okay, but that's it. We've got the mean, we're done. If you wanted to work it out longhand, so adding the values, dividing by 12, that's fine. But what's nice is that even though it took a little long to put in my data, I have it there when I now need to do the standard deviation a bit later. Okay, so we've got the mean sorted. Question B says, what is the modal? No, it doesn't. It says, what is the mode for the number of wins per athlete? So you've already told me what mode is. Who can tell me what is the mode value here? Nice, guys. Okay, so our modal number of wins is 5. And the reason for that is because that is the number that repeats the most. There were 4 5s. Everything else was 3 or less. Done. Now it's asking me to draw a box and whisker plot for this. Now, does anyone know what 5 numbers I need to have to draw a box and whisker? You don't have to give me all 5, but can you tell me some of them? Okay, Angie's got a good word there, 5 number summary. So what are those 5 numbers? I see 2, which are great. Nice. Nice, guys. Okay, so you need a 5 number summary, basically. Now, sometimes we do ask you as a separate question, what is your 5 number summary? In this case, I've just thrown you straight into draw a box and whisker, and I expect you to know that you need the 5 number summary. So this is your minimum, your Q1, your median, or Q2. I don't really mind what you choose to use. I say median, but Q2 is absolutely fine. Q3, and your maximum. Now, unfortunately, because this data set isn't ordered, we will need to put it in order first before we can get any of those values. So when I say put in order, we need to arrange the number of wins in ascending order. So the lowest was 2. Then we had 3 3s, 2 4s, 4 5s, and yes, you do have to write all the repeats. No 6s, a 7, and a 9. Okay, so we've got our data set, it's ordered. We can now go and find these things. So the minimum is 2. The maximum is 9. Now, how you choose to find your median and your quartiles is up to you. Some people have formulas, n plus 1 over 2, fine, I don't care. I don't do it like that. I've never done it like that. I don't find it makes sense for me. I just can't. Now I know that there are 12 data points in this data set. So smack bang in the middle will be between 6 and 7. So 1, 2, 3, 4, 5, 6. There's my median or Q2 value. Woo! Okay, halfway between 4 and 5. We'll chat about that in a second. Now what I've done is I've split my data set in half. So one half of my data set has 6 values, the other half has 6 values. So to find the quartiles, I just find the midpoint of each of those halves. So the midpoint or Q1 would be between 3 and 3, and the midpoint or Q3 would be between 5 and 5. That's how I do it. If you have formulas that you use, that's fine. It makes absolutely no difference as long as you understand what you're doing. But what you can hopefully see is that the split has now got 3 data points in each quarter. It's evenly split, 3, 3, 3, 3. So our quarters are perfectly representing 25% of my data set. So now I can go and state what those other 5 number summaries are. So Q1, halfway between 3 and 3 is just 3. Our median, halfway between 4 and 5 is 4.5. And halfway between 5 and 5 is just 5. So now I can draw my box and whisker. Okay, Camilo's asked for the other method. I'm going to be honest, Camilo, like there's so many other like variations of it. So the one way that you can do it is to say n plus 1 over 2 to find your median. So basically this would be 12 plus 1 over 2, which is 13 over 2, which is 6.5. So what that is saying to you is that your median is at the 6.5 position. So basically between 6 and 7. The reason I don't like this method, and I'm saying this having like marked paper 2 literally today, so many kids will go and do this beautifully, but then will tell me that that's their median. That is not your median. This is the position of your median. You still need to go and work out where 6.5 position is, and then go and tell me what the value is there. So all this method does is tell you the position of Q1, Q2, Q3, whatever. So some people then also use n plus 1 over 4 for your quartiles, which would be 13 over 4, which again, like it's not just giving you gross numbers. 13 over 4 is 3.25. So it's saying it's between the 3rd and the 4th, which we've already established it is. Some people just use n over 2. So 12 over 2 is 6, tells you there's 6 in one half, 6 in the other half. But again, the reason I don't like this method is because so many students just stop at the position. They think that that is their median. It's not. All this does is work out the position of your median or of your quartile 1 or 3. You still need to go back to your data set, figure out where that position is and what the corresponding value is. So that's my personal, let's not say issue with it, but just why I won't use it. Okay, because I know that often kids just stop there and that's actually not correct. Okay, but we want to draw a box and whisker. So I know that the minimum number of ones I need to represent is 2, the maximum 9. So I'm just going to go up in ones. Now guys, for a box and whisker, your number line does not need to start at 0, nor does it have to go up to a specific value. You start, my advice is start, if you're going to go up in 1, start 1 below, go 1 above. If you're going up in 5, start 5 below, 5 above, just sort of go like that. You don't have to start at 0. I have written down the formulas. Let's just take note. So formula for your median. So this is Q2. Yeah. And this over here is for your quartiles. So this would give you quartiles 1 position. You would then need to add those positions to get median quartile 3. Again, it's just why I don't like it. I don't think it's a useful formula. Some people use, and let me not get this wrong now. Let me just make sure that I'm not talking nonsense to you. I'm talking nonsense to you. Okay, so this would be for quartile 1. If you wanted quartile 3, okay. You wanted quartile 3, you would say 3/4 of n plus 1 over 2. So that would be quartile 3. Yeah, and like I said, I don't use them, I don't like them. Yeah, Kirsten, I've got that there already. It's right here. That's, I mean, it's the same thing. Half times n minus 1 or n plus 1 over 2, it's the same thing. You're dividing by 2. So whatever you want, I don't like them. If you want to use them, use them. Okay, I'm doing box and whisker. Your formulas are all there if you want them. I'm on the box and whisker. Minimum. Now, guys, I use vertical lines. So every minimum Q1, Q2, blah, 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 I use a vertical line. I'll show you what some other people do. I don't care if you do it. So that's my minimum. Q1, median is 4.5, so between 4 and 5, then 5, my maximum at 9. You join the middle 3 lines to form your box. From Q3 to your maximum is a whisker. Minimum to Q1, another whisker. Some people draw the ends of the whiskers with a dot. Pick one. Either use a dot or line. Again, I don't care. It's the same thing. I don't use dots. I use lines, but if you use dots, absolutely fine. Okay. So if you draw a box and whisker with dots on the end for your whiskers, I don't. I use lines, but again, it makes absolutely no difference. Right, so we've drawn our box and whisker. You need your 5-number summary. I've shown you ways that you can do it with formulas or just count. If you want the formulas, they're all there for you. Just in case we're still not seeing. So there's the Q1 in green and Q3 in blue. Okay, Q2 or your median is in pink at the bottom. And again, if that's what you choose to do, that's absolutely fine. It's just not something I would choose to do. Okay. And again, my reason for it is because you use this formula and then you don't actually go and work it out. You figure out what position it's in and you stop. You don't go back to your data set. That's wrong, unfortunately. Okay, you won't get marks. Right, so we've drawn our box and whisker, and now it's asking us in question D to comment on the distribution. And so what we need to do is we need to understand what that actually means. So it's saying in terms of skewedness. Right, so what is skewedness? Well, let's have a look at this table over here. This is going to tell us about skewedness. Now, skewedness talks about how certain values in our data set affect the data set. And generally, again, it's going back to this idea of spread. Okay, so you're all saying things. I haven't explained anything yet, so just hold on a tick. Let's just understand what skewedness is before we go. Right, so if something is positively skewed, what I need you to remember is that every portion of your box and whisker represents 25%. So from minimum to Q1, 25%. Q1 to median, 25%. Median to Q3, 25%. Q3 to maximum, 25%. It contains equal parts of your data. The size of the whisker or of the rectangle in your box represents how it is distributed or what the dispersion or spread is. Now, what you can see if something is positively skewed is that the top or the upper 50%, so from your median to your maximum, is way more spread out than the rest of your data set. So if you have a look, this represents 50%, but this also represents 50%. Those portions contain the same number of data, but the bottom 50% has data points way more close together in value than the upper 50% where they're a little bit more spread out. So that is what positively skewed means. Negatively skewed, on the other hand, is basically the converse of that. Again, remembering that every little segment here is 25%, so they all contain the same number of data points. Their size or their width is just telling us how the data is distributed. So if we now have a look at a negative skew or a skew to the left, what we see is that it's now the bottom 50% that is more spread out, okay? These all contain the same number of values, but this bottom 50% is way more spread out than the top 50%. And we can think of this in terms of an actual example. So positive skewed is when you've got values that are spread out in your top 50%, but which often they mean that they are pulling up your mean. Okay, so essentially, if you think of like a test, if you have got everyone getting like 40s and 50s, but then you've got two people who got 100% for a test, that's going to pull your mean up, and it is going to have values that are now much bigger on the positive side of your number line. And so it is going to positively skew your data. Sorry, it pulls it up. On the same vein, everyone could get maybe 60, 70% for a test, but then you get two people who get 5%. Those low values pull the spread of your data out towards the left and negatively skew your data set. So in this case, unfortunately, no, it is not skewed to the left, it is skewed to the right. If we go back up to our data set, or our box and whisker rather, remember every segment here is 25%. The upper 25%, the upper 50% is way more spread out than the bottom 50%, way more. And so that means that because this upper 50% is much more spread out than my bottom 50%, it is positively skewed or skewed to the right. And you can see that also if you just go back to the reference box and whiskers. Now, it doesn't matter if you say positively skewed or skewed to the right. They mean exactly the same thing. I usually say skewed to the left or the right, but it honestly makes no difference. I say left or right because I then look at where is the spread greater. Is it greater on the right? Then it's skewed to the right. If the spread's greater on the left, it's skewed to the left. I just find it easier to remember like that. But basically, skewedness is where is the upper or lower 50% more spread out. Okay, so question E says calculate the standard deviation. So we need our calculator again. It's already got all of our data on it, so it's not like we need to re-enter data. AC, shift 1, 4, and now we want standard deviation. Standard deviation is represented by sigma. So we want to choose the symbol sigma, which is number 3, and that will give us our standard deviation. Now it says to 1 decimal point, so we make sure that we round off appropriately. The second decimal point is a 4, so it has no effect on the 8. So our standard deviation here is just 1,8. Putting the x there means the standard deviation for x. That's it. Okay, calculator work. There is a way to find standard deviation manually, but it takes a lot of time, a lot of effort, a lot of calculations. There's a question's asked, so you look where the space is more prominent and not where the box is closer to. I suppose you can do it either way. I look at where it's more spaced out because I know then if it's more spaced out on the right, it's skewed to the right. If you do it the other way, you say, okay, cool, it's closer, or yeah, the box is more closer on the left, then you know it's skewed in the opposite direction. So it just depends which way your brain is going to work. I look at it as where is it more spread out, which 50%, bottom or top. Top 50% skewed to the right, bottom 50% skewed to the left. But you can, you can think of it conversely if you want to as well. Just then remember it's the opposite. Right, and now question F is what we would say is a complex question, but honestly really is not. Okay, so this is the question that we often fumble on because I think we don't understand what it's asking. So it says, how many athletes lie outside the first standard deviation interval? Now, firstly, what the hell does that mean? Probably shouldn't say, what on earth does that mean? So within one standard deviation interval means, now remember we said standard deviation is the measure of spread of our data set about the mean. So here's your mean, your standard deviation, an interval on either side is one standard deviation above, one standard deviation below. So you would add a standard deviation, subtract standard deviation, that is one or the first standard deviation interval. Now, generally we say that data within the first standard deviation interval of the mean is a good representation of your data. As you start to move out and out and out, you're starting to get closer to points that might be outliers and might be skewing your data set. So often within one standard deviation is a pretty good reflection of your data set. So we now need to actually go and do this. What that means, what this first standard deviation interval means, is that we want to take our mean and we want to add and subtract our standard deviation. That's it. That will give us the interval. So if I take my mean and I add a standard deviation, that means I'm going to have 4,58 plus the standard deviation that I just worked out, 1,8. And that gives me 6,43. I want to do the same by subtracting a standard deviation. So 4,58 minus 1,8, and that gives me 2,73. What you have done is you found the interval. So we're saying the value of x, so the number of wins, should be within the interval 2,73 to 6,43. As long as your number of wins is from 2,73 to 6,43, you're in the first standard deviation interval. So this is now where we need to go back up to our data set and figure out which is which. So 2,73 and 6,43. Yes, okay. If we go and have a look at which ones fall outside of that range, because it said how many fall outside the first standard deviation. 2 definitely falls outside it because it's less than 2,73. And the 9 and the 7 fall way above the 6,43. So they also fall outside the first standard deviation interval. And so this would be 3 athletes' wins that fall outside. So there are 3 athletes that fall outside the first standard deviation interval of our mean. Kirsten, I'm assuming you're asking for the standard deviation question. It depends on the question, but this specific question, I would probably only give 2 marks. So understanding the method of needing to add and subtract, and then a mark for your answer. If we were feeling a bit more generous with marks, a mark for adding, a mark for subtracting, a mark for your answer, but 2 or 3 marks max, nothing more than that. Right, question G says, why is Bruce Fordyce's number of wins an outlier? Give a mathematical reason to justify your answer. So there is a mathematical way we can find outliers. I'm going to show you that in a second. But let's just go and double check what his value was. So Bruce Fordyce is over here. Just grab a nice big highlighter. And he had 9 wins. That was our maximum. And if we go to our box and whisker, there's the 9. That is the value that's pretty much skewing my data to the right. So there's definitely something, let's not say special, whatever, but there's something interesting about that data point and its effect it's having on my data set. And so this is now where this idea of an outlier is going to come in. Can anyone tell me what an outlier is before we jump into this? What's an outlier? Okay, cool. So someone say data that lies outside the standard deviation. Generally, we can use that as a bit of an indication. for sure, because especially like I said, the more standard deviations we have to add, the further and further away we're getting from our average. Right, so very basically an outlier is a value that is different, vastly different to the rest of your data set. And it goes back to this idea of test marks. If everyone's getting 40s and 50s, but all of a sudden someone's getting 10%, they're an outlier. They are very different to the rest of the class in terms of their marks. And so we can mathematically determine outliers using essentially our quartiles, because remember our quartiles represent the middle 50% of our data. The middle 50% is generally where your averages all lie, the mean, the median, the mode. That's your middle 50%. If we now go to the lower 25 and the upper 25, that is where we're going to start to find our outliers, either very, very low or very, very high. And I'll write the formulas down in a second, but basically what we do is we say, okay, cool, Q1 represents the lower limit of my middle 50%. We always give a bit of leniency because obviously data, there's always room for error. And so we say, okay, cool, I'm going to take the range from Q1 to Q3 because that's the difference, the spread of the middle 50%. And I'm going to times that by 1.5. Just, a little bit extra on the minimum, and then I'll add to Q3 a little bit of extra on the maximum. A little bit of leniency, a little bit of wiggle room. But if I fall within that range, I'm not an outlier. If I then fall outside that range, I'm an outlier. Oops. So we are looking for values of X, so number of wins in this case, that are less than quartile 1 plus 1.5 times the interquartile range. Again, all this is saying is quartile 1 is our lower limit. The range, so the difference between Q1 and Q3 is a spread, and we're going to accommodate for a little bit of leniency on either side. So that's one formula for a lower outlier. For an upper outlier, we're looking for where it's greater than Q3 plus the 1.5 times our IQR. And then you just go and work that out, okay? Now, we don't need to go and work out the lower limit because Bruce Fordyce is the specific question we've been asked here, and he's on the upper end. So you can go and work out an outlier that would be much smaller, but in this question, it's not important. In this question, it's important for us to use the upper. So Q3, we already know is 5, and we want 1.5 times our IQR. Now, remember, Q3 was 5, Q1 was 3, so we're saying 5 minus 3. So our IQR is 2. There's a difference of 2 wins between Q3 and Q1. 2 times 1.5 is 3. So 5 plus 3, which is 8. So essentially what we're saying is we want any X values, or we know that any X values, number of wins, more than 8 are outliers. Now Bruce Fordyce was 9 wins. And our outlier would be considered where X is greater than 8. So therefore, it is an outlier. Okay, so you can use your quartiles and interquartile range, the spread of your middle 50%, to determine whether or not something is an outlier. So box and whiskers sort of give you a bit of a visual indication of when there's an outlier, particularly when it is very much skewed in one direction, like our box and whisker was here. It was very much skewed to the right. When we start talking about scatter plots and stuff next week, it will be also fairly obvious on a scatter plot that one point is very much deviating from the general trend of your scatter plot. So you can again identify outliers, but mathematically, if you wanted to, you've got these 2 formulas here that you can use to essentially determine whether or not something is an outlier. Okay, so those formulas again are here. And remember, outlier is looking at how far away it is from your central point. So that's why we can use IQR, because that is a spread measure. Right, so let's take some screenshots of this question. We're going to have to do it in parts because there's a lot. So part 1, A, B, and C. You can get D, but it's cutting off the box and whisker, so I'll get it now. While you're screenshotting, Melo.
Ma'am, about the box and whisker, are we supposed to label our minimum, maximum, and the quartiles?
You can, but you don't have to. I actually usually do. It's weird that I haven't done it yet. You can, but you don't get marks for it. We mark you based on where you've drawn your box and whisker, not whether or not you've labeled it. We assume that you have correctly found in a 5-number summary, and then obviously the number line makes you draw it in that order. But if you want to label it, that's absolutely fine. I actually usually do, so it's absolutely fine if you want to.
Thank you, ma'am.
Sure. Right, and then what did you get? Okay, so you got all of that, so we can do that. Right, the last 4. Oh, yeah, thank you. Losing it. Guys, sorry, it's Q1 minus, not plus. Aye. Let's draw a triangle, why not? Okay, so minus. Thank you. Right, now guys, there's 5 minutes, and I don't think you will be able to do this all in 5 minutes. I'm gonna put it here. You're gonna work for 5 minutes. But you're gonna take a screenshot, and then I will put up the answer at the beginning of Wednesday's lesson, so you can double check whether or not you've gotten it correct. I've been nice in this example. I've ordered your data set for you. So you do not need to put those values in order. They are already from smallest to biggest. You don't need to do that. So it means that you can answer your questions quite easily. Okay, so for these last 4 minutes, let's work through this. If you've got questions for me, ask. I'll see where you're at in 4 minutes. I don't think you'll be finished though, but we'll see. And if you are finished, I'll give you the answers. Milo, sorry, I don't know, my brain did not like register your message. Where do you need me to go up to? All the way to the start or just the last four? Sorry, just did not register at all. Start, okay.